Okay, welcome to mathematics class. In today's episodes, we are going to be talking about geometric progressions. Geometric progressions. In our previous episode, we talked about arithmetic progression under sequence and series. Under series, we talked about arithmetic progression in our last episodes. And I gave you some questions to play around with. Let's see the answer to those questions. Here are the questions given in episode 3 of this series. Episode 3. I gave you exercise 6C. Yes, for those of you that attempted the whole questions, well done. So here are the answers to those questions. You can pause the video and double check if you are right or wrong. If you have not seen the video on arithmetic progression, go check it out and try out those questions before you will check these answers. Okay, that's it. And that is the answer. Well done. Great job for your attempt. Okay, let's continue with today's class. We're talking about geometric progression. At the end of this episode, students should be able to recognize and solve problems on geometric progression. You should be able to recognize, yes, and solve problems on geometric progression. Before we kickstart the class, give this class activity a shot, and when you are ready to see the answer, please play the video. Yes, give it a shot. You can pause the video now, and when you are ready to see the answer, you play the video. Thank you for making attempts. Let's see the answer to these questions. Here are the answers to the starter activities. Yes. Well done to those people that got the 3 questions. But if you are finding it difficult to get the answer to these questions, this episode is for you. Come, let's discuss geometric progression. All right, in our O-level mathematics or IGCSE mathematics or elementary mathematics, we are used to number patterns. And in our last episode, I told you when you have a number pattern that we call sequence, they are set of numbers that has a specific rules that governs them. That have a specific rule that governs them. And I told you, if such a number is demarcated with a comma, then you call them sequence. But if it's demarcated with a sign, either plus or minus, then it's a series. So in this episode, talking about geometric progression, or what you refer to as exponential sequence or exponential series, is a type of series or sequence in which there is a common difference. Common difference. When you have a series or sequence in which there is a common difference, then you are talking about geometric progression or exponential progression, exponential sequence or series. Let me give an example. Maybe I have something like 1, 2. If I have 1, 2, 4, 8, and so on, this is a geometric progression. Okay, let's get into it. Just to recall what you've learned so far in your O-level math. The first term of any sequence, any series or sequence is always the first term A. Like if I have 1, 2, 4, and 8, my 1 here is A, My 2 here is the second term. Here is called the third term. Here is called the fourth term, and so on like that. The last one here, your n here will be the nth term. And if you want to calculate your common ratio R, it will be the ratio of your third term to second term, or your fourth term to your third term. Am I communicating? So for this series that we have here, that I gave to you in the question, -1 -2 plus 8 plus 4 minus 8 plus dot dot dot. My first term A is 1, my second term is -2, my third term is +4, and my fourth term is -8. For me to calculate the common ratio, I will just say the third term minus second term, which will give me -2, or I will say the fourth divided by the third, it will still give me -2. That's just it. Geometric series. The first term is always A, and your second term is AR. The third term is AR squared. The fourth term is AR cubed. This is my first term. This is my second term, U2. This is third term. This is fourth term. If you look at it very well, as the number of terms increases, the ratio is reduced by 1. For the second term is AR. For the third term is AR squared. For the fourth term is AR cubed. What will be for the seventh term? Yes, for the U7. Thank you very much. U7, it will be AR raised to the power 6. And what will be the UN? Yes, the nth term. Yes, the nth term. It will be AR is reducing by 1. N raised to the power -1. N raised to the power -1. And that is how to get the nth term of this. So these are the formulas that we need to put in mind anytime we are dealing with this. The common ratio is always U3 over U2, and my UN will always be ARN minus 1, where A is the first term, R is the common ratio, N is number of terms. You can also ask to calculate the sum. When you want to calculate the sum, it depends on your common ratio. If the common ratio is greater than 1, the formula will be -1 over R minus 1. This is when your R is greater than 1. And when your R is less than 1, we have 1 coming forward all over 1 minus R. And here, R less than 1. You can also ask to calculate sum to infinity of a common geometric progression. The sum to infinity is denoted with this symbol, and it's always A all over 1 minus R. In such case, your common ratio will be less than or equal to -1 less than or equal to R less than or equal to 1. So it will always less than 1. When your common ratio is less than 1, you can calculate sum to infinity of that geometric sequence. Let's apply. Okay, Looking at these examples, I will just do maybe one or two. I will do one in question 1, do one in question 2. Number 1C. To do number 1C, my first term is 40, my second term is minus 20, third term is plus 10, and fourth term is minus 5. The question asks me to calculate sum to infinity, but let's quickly look at this question and rephrase it. I may be asked to calculate common ratio. Let me just write out an question from here. If you are given 4, this, this, and this, they can ask you to find the seventh term. They can ask me to find the sum of the 10th term, the sum of the first 10 terms of this sequence, and they can ask me to find the sum to infinity. Sum to infinity. So I'm treating it with these three problems or three questions. Sum to infinity. So let's quickly apply it with this. Now, let me first quickly calculate my common ratio. I've said it that a geometric sequence or a geometric progression is a type of series or sequence with a common ratio. Common ratio R will be my U3 over U2. It can also be U4 over U3. So anyone we want to use, let me use U4 over U3. That is minus 5 over 10, which will give me minus half, minus 1 over 2. So the question asks me from the one I drafted, he asked me to calculate U7. If I want to do U7, the formula for calculating that is ARN minus 1 as the power. So my A is 40, times my R, which is half, raised to power 7 minus 1, which will be 40 bracket 2 raised to power minus 1. Law of indices allows that, and I can have 40 bracket 2 raised to power minus 6. You can use your calculator to simplify that. I'm just trying to apply this. So the question asks me to calculate the sum of the 7th term. In as much as my radius is less than 1, r is less than 1, I'll use the second formula, which is A 1 minus Rn over 1 minus R. So my R less than 1. So my A still remains 40 or plus 40 minus 1 over 2 raised to power 7, all over 1 minus 7. Just type everything into your calculator and you do this very well. If you do this very well, from my calculator, it can tell you to put it into, maybe let's just do 0.61 to 2 dp, 2 decimal places, and that is how to do that. So the last question under this is to find the sum to infinity. I've told you we want to find the sum to infinity of that series A1 minus R, which is my A is 40 and 1 minus half, and that will give me 40 over half, and that will be 80 straight up. Quickly do question 2 very fast. I have the series, it's a sequence 1 0.5 squared 0.5 raised to power 4 and 0.5 raised to power 6. So if you know you can solve this question, pause the video, and when you are ready to see the answer, please join us. This one is still the same thing as 0.5 5 raised to power 0, as we know that any non-zero digit raised to power 0 is 1. Okay, I have 0.5 squared, and I have 0.5 raised to power 4, 0.5 raised to power 6. So this is my first term, this is my second term, my third term, and my fourth term. Okay, let me first quickly calculate my common ratio. When I use U3 over U2, which will give me 0.5 raised to power 4 and 0.5 raised to power of 2. So I can simplify this, pick the common one, and 4 minus 2 will give me, the common ratio there will be 0.5 raised to power 2. Okay, I'm calculating sum to infinity. So I will just do sum to infinity of that one straight up, which will give me my A. I've told you A over 1 minus R, such that minus 1 less than R less than or equal to 1. So I'm going to have the first term, we know it is 1. I can also use 0.5 raised to power 0. 1 minus 0.5 squared. So I can type that one straight up on my calculator. 1 minus 0.5 squared, and that gives me 0.75. So 0.75 is 0.75 over 1. So 1 minus my answer, 1 divided by my answer is giving 1.3333. So the final answer here, sum to infinity, is 1.333 repeated. So it's 1.33 to 2 decimal places. So I'll give you some questions to practice. So practice question, exercise 6D. Yes, those are the questions to 6D. Yes, 6E. So these are the questions on infinity, sum to infinity of a geometric progression. So please keep solving math, keep practicing math. See you in my next episode.